Okay, so let's go over the problems on quiz number 8. So the first one talks about a safe where you have to pick 3 numbers correctly in the right order. So the question is, how many possible options are there to try? So that means we can choose from out of 60. But we're only picking 3. And because it's a safe, if we choose the right numbers but the wrong order, it won't open. So that means this is a permutation. And so we use the formula 60, that's how many we have to start with, over 60 minus 3 factorial. And that's the same as 60 factorial over 57 factorial. And if we cancel things away, what we're left with is 60 times 59 times 58. And that is equal to 205,320. And so there's our answer for number 1. With number 2, we have 6 options. We're picking 3 classes. And again, if we change up the order, it's a different schedule. So this again is a permutation. So here we have 6 factorial over 6 minus 3 factorial. And so that's equal to 6 factorial over 3 factorial. And if we cancel things out, that's equal to 6 times 5 times 4, which is 120. So for number 3, we have to expand this binomial. So first off, it's being raised to the 5th power. So the numbers out in front are going to be 1, 5, 10, 10, 5, and 1. And so we start with 2x to the 5th power, and then 2x to the 4th, 2x to the 3rd, 2x squared, and 2x. And then we have minus 5y. So we have minus 5y, minus 5y squared, minus 5y cubed, minus 5y to the 4th, and then minus 5y to the 5th. Now the thing that people forgot was that this is not the complete binomial. You have to multiply all these terms and write them with a single coefficient. A lot of people tried to pass off this as an answer, and they needed to show me an expanded answer. So the expanded answer looks like this. 2 to the 5th is 32, x to the 5th. 5 times 2 to the 4th times negative 5 means we're going to subtract 400, x to the 4th y. 10 times 2 cubed times negative 5 squared is going to be positive 2,000, x cubed y squared. 10 times 2 squared times negative 5 cubed is negative 5,000, x squared y cubed. 5 times 2 times negative 5 to the 4th is positive 6,250, x y to the 4th. And then finally, negative 5 to the 5th is negative 3125, y to the 5th. And so this is the fully expanded binomial. On to number 4. Here we're raising this to the 4th power, so our coefficients are 1, 4, 6, 4, 1. We start with square root of x to the 4th, and then square root of x cubed, and square root of x squared, and square root of x. And then we multiply that by 4, 4 squared, 4 cubed, 4 to the 4th. And again, we need to expand this out. Square root of x to the 4th power means that that's going to equal x squared. 4 times 4 is going to be 16. But we're only multiplying by square root of x 3 times. So that means we have 16x, but we still have an extra square root of x left over. 6 times 4 squared, that's going to be 96x. Next, 4 cubed times 4 is 256 times square root of x plus 256. So that is the expanded form for number 4. With number 5, we want to find the term that contains x to the 6th. And because it's to the 8th power, the numbers that we are using is going to start 1, 8, 28, 56, 70, and then go down 56, 28, 8, and 1. Now our first term is going to have x squared to the 8th power. Well, that's going to be x to the 16th because we would multiply the exponents. We don't want that term. The next term would be x squared to the 7th. Well, that would be x to the 14th. So I have to keep going until I find the one term that has x to the 6th. Now, because I have x squared inside, that already accounts for a factor of 2. So that means I'm going to be taking x squared and I'm going to be raising it to the 3rd. And so this is the term I'm looking for. But a lot of people stop short on this problem. They stopped short and just said 56, or they said 56x squared cubed. But there's the other part. There's negative 5 to the 5th. And so we still have to figure out, well, what is 56 times negative 5 raised to the 5th power? That's our coefficient. And so our answer is negative 175,000 x to the 6th. That is the term here. Number 6. Here we want to find the probability of flipping a fair coin 4 times and getting at least one head and at least one tail. So we have two options, heads plus tails to the 4th power. So if we expand this binomial, there's one way to get 4 heads, 4 ways to get 3 heads and a tail, 6 ways to get 2 heads and 2 tails, 4 ways to get 1 head and 3 tails, and 1 way to get 4 tails. Now we are interested in getting at least 1 head and at least 1 tail. So we're concerning ourselves with these 3 middle terms. So what we do is we substitute 1/2 in for heads and 1/2 in for tails because it's a fair coin. And once we do this, then we'll punch this into our calculator and get that probability. And that probability should be 0.875. We don't include this because it has a head, but it doesn't have a tail. Vice versa with this. It has a tail, but it doesn't have a head. But each of these 3 has both a head and a tail. So those are the terms that we count. And finally, with number 7, we're taking a 15-question multiple choice test, and we're answering at random. And, well, we can either guess right or wrong 15 times. Now, this is quite a long binomial. The first term would be r to the 15th. The second term would be 15 r to the 14th w. And there'd be a lot of terms in the middle. The second to last term would be 15r w to the 14th, and the last term would be w to the 15th. Now what we're asking for is we want the probability of getting 2 or more right. Well, that's a lot of terms. In fact, it's all of these. Well, like I said in class, there's an alternative way of solving this. Look at the 2 things that we don't want. Let's find those and then subtract them from 1. Now, because it's a 4-question multiple choice, that means we have a 1/4 chance of getting any question right. and then we have a 3/4 chance of getting it wrong. So I put 3/4 in for W and 1/4 in for R. And so when we calculate this, type this in, 15 times 1/4 times 3/4 raised to the 14th minus 3/4 raised to the 15th. And so we get 0.719 as our answer. All right, hope this helps.